Limit is y goes to 2 of y squared minus 4 divided by sine of 3y squared minus 12. The first thing I'm going to do is plug a 2 in for each of the y's. That'll give us a 2 squared minus 4 over the sine of 3 times 2 squared minus a 12. In the numerator, 2 squared is a 4 minus a 4. Over, in the denominator, we have the sine of 2 squared, which is 4, times 3, which is 12, minus 12. 4 minus 4 is a 0. Over, sine of 12 minus 12 is a 0. So we have the 0 over the sine of 0, which is the 0 over 0 indeterminate form due to a power function and a trig function. So we're going to make use of the identity. Limit is theta goes to 0. The sign is actually in the denominator here, so I'm going to write the reciprocal version of it. It still equals to a 1. We have to match the other position with the phase of the sine function. So our first step is to isolate the sine function. It's in the denominator. Y squared minus 4 is in the numerator. These are multiplying fractions, and so they still equal the original. And we're going to put in the other position, matching the phase, 3y squared minus 12. Now to compensate for that in the other fraction, I'm going to put that in the denominator so that they would cancel out with each other, and it's a form of 1. Our next step now is to work with the other fraction, because it looks like we have power functions and we can factor cancel. There's actually a 3 that factors out of the denominator power function, and those power functions can cancel, leaving us with a 1 in the numerator. This first limit is the perfect form since both are going to 0 and we've matched the phase. It's the perfect form of the identity, and therefore is equal to a 1, and we have a 1 times a 1/3, which is a 1/3.